Happiness, we're alive. You can start now, please.
Okay, thank you. Good evening, everyone. I'm so sorry. I've been having a bit of network challenge. That's why we are starting now. So I'm sorry about that. So today we'll be talking about building smart contracts with Solidity, inheritance, and libraries, and then oracles. So let's go into them now, one after the other. When we talk about building smart contracts using inheritance, libraries, and oracles, all we are talking about is code reuse, meaning that there's a code somewhere that you want to use. It can either be personal codes, codes that you yourself wrote, and then you see that there's a need for you to use it over and over again in different projects. And so it's one way it's one way to talk about code reuse. That's a personal code, and then you have external codes. That is codes that you are not the one who wrote them, but they were written, and then they are codes that you want to use to implement in your own code. So when we talk about this, either using your own personal codes or external codes, then it brings us to libraries, contracts, and oracles. These codes can either be libraries, they can also be contracts, or they can be oracles. So it's just like you have projects that you know that you require a particular type of code to use them again and again. So you don't need to start writing these codes all the time. You want to do that a different project, but you need a particular type of code. You don't need to start writing that code over and over again. You can just have them stored as a library that you can use again. So that's one way to use. And then these external codes, there are some codes that meet a particular standard that have been implemented, such as ARC20 codes and ARC721 codes. So these codes can be used by anybody. And so these ones are external codes that can be used. And then we'll have oracles. So let's go to see how this we can have these codes reused. They can be used as libraries. Libraries are similar to contracts in appearance, but you can't declare any state variables and you can't send ethers. So just as you write smart contract code, you can write codes that are libraries that you would want to use again, or there are some codes that are libraries that are stored and then you can use them. Those ones are external types of libraries. So we'll be looking at examples of such libraries, either a personal one or an external library code. So we'll be looking at examples of them practically now. Coming now to share. So this is Remix. I already have a code here that you can see. This is an example of a personal library. You can see that this part of it, I'm coming, let me expand it so you can see. Okay, so I'm sure you can see it now better. So this code has library. When you write codes that are library, you use the keyword library. You don't use contract. Use the keyword library for such codes. And so this is a code that is a library here, and then you see it here. But then you are using it in your code. You are using it inside your code. And so you see from here, you are making use of that code that you have written. It's right here inside this code. We're going to look at it when it's not here. In that way, you have to import it. But for now, let's look at it here, right here. So you have it, you have the library code right inside your code, your contract. Your contract. We have two of such library code. The first is named Safe Math and the second Math. So here you can see that you are using this Safe Math library in your code. And you are calling this function of the math library. You can see this is a math library here. So you are calling this the function square roots in this math library in your own function, in your own contract function here, the contract test safe math. You are calling the library code here, the function of the library, the math library, the function square roots. You are calling it in this your contract here. So you are using that library contract, that library code, I mean to say, not contract. It's not a contract, it's a library. So you're using this library code in your contract. And so you have to put it here, and then you're making use of it using safe math for you ends. And you're also calling this function of the library math in your function here. So an illustration of this personal library is just that, like, as you have, let's take for example libraries where we keep books. Maybe there's a particular book or some books that you would want to refer to from time to time. You can store them in your own personal library. You have a library where you can go back and then use those or read those books or use those books from time to time. But then they can also be an external library. That's a library that is not owned by you, but then you can go there to also take books to read for your own personal use. So this one is your own library that you have created, and then you are using the code in your contract. But then, must we have this library inside our code in order for us to be able to use it? Must we have the library in our code? No. The answer is no. We can have this library somewhere else, saved somewhere else, and then use it in our code. So we'll be looking at how we can do that, how we can use a library code that is not saved in our contract, but in our own, that is not saved, that we don't have right here in our code, in our contract, but we can also make use of it. So I have an example of that. You can see my screen here, right here. Now, remember we had two libraries in our code, in our contract that we looked at previously. But now here, we don't have those library codes right here. We just have this contract code. The contract code that has a state variable and then two functions. That's what we have right here. But we are also using the library in this code because look at, it says using safe math for you int. And then we are calling the function of the library math in this contract. But how are we making use of it? That brings us to the use of this import. So when we make use of a library that is not in our code, we don't have it right there in our code, we have to import it. But then, where are we importing it from? you can see this is stated library slash safemath.so. Why is it like this? It's telling us the location of this particular library. Now, look at where it is. Look at where we can find it. It's in a folder named library. It's in a folder named library. And then when you open the folder, you can see them here, safemath.so and math.so. So that's what it's telling us right here, that we'll have it in a folder library, and then it is saved there as safemath.so. And this one too, it's also in that folder libraries, and then the name of the library is math.so. So by using the import keyword, we can import the libraries into our contracts and use them. So this is how we make use of libraries. But then we can have external libraries, like I said earlier. So where can we find such libraries, external libraries? One example of that is the Open Zeppelin. Sorry, come in. Okay, so if you go to GitHub, and we type in Open Zeppelin, sorry, GitHub, I mean to say. So we can search for Open Zeppelin contracts. Now we have contracts here. We have contracts. Then we'll check under utils. Now let's see. Look at this. This is an example of a library. You can see it has the keyword library safemath. And so this is a library that we can use in our code. If we're writing a code and we know that the code, we have, this library has some codes that we need to implement in our own contract, we can then make use of this library. But then you see, when making use of it, it's Open Zeppelin slash contract slash utils slash math slash safemath.so. That's where that is showing us the location of this library. So you can copy this URL. You can copy this URL and then use it to you can then import it into your remix here. You can see it here, it's under GitHub. You can see Open Zeppelin contract. You see, it's telling us the location of this contract here. An Open Zeppelin, and then it's inside the contract folder, token, utils, and then to math. Contracts, utils, and math. So we can use that in our own code. Let me just show you an example of how, for instance, this is it. Okay. So you can just, for instance, let me write that out. Contracts. It's already there. So that's how, to show us the location of this particular library in GitHub, you can see the order: Open Zeppelin, contracts, utils, and maths. And then the name of the library is safemaths.so. Okay, we don't have maths here, sorry. Okay, so that's how you import an external library into your own. Okay, it's just an example. I'm just showing you an example of how to do it. So it's not going to work in this my code here because I already have the libraries I'm making use of in this code. But just to show you an example of how to import an external library into your code. So that's what I'm just trying to do here. So this is how to make use of libraries in a code. This is how to make use of libraries in your own contract. While writing your contract, you can import libraries. That is a code. That is a code that you need, and then use it in your own contract. And so it can be either a personal code or external code. That is a code that you yourself have written before, and then it's saved somewhere, but then you have a use for it, and you import it into your contract. But it can also be external, that is not yours, but there's a code that has already been implemented that you need while writing your own contract. You can import it, just as we did for this Open Zeppelin library. So that's how to use library in Solidity, in smart contracts, when building smart contracts. So we'll be talking about using inheritance. Okay, so we are done with the libraries, but what about inheritance? When we talk about inheritance, what comes to our mind is contracts, because we said when using the libraries, we use the keyword library. But when talking about inheritance, what comes to our mind is contracts. And so how can we understand this inheritance? You can think of it in a normal or natural way, where we have parents and a child. So The parent there is the base contract and the child is the derived one. And so when talking about inheritance, we use the keyword is. So this inheritance, what it's all about is just avoiding redundancy. That means you are writing codes that have been written before all over again, but you just reuse a code that has been written before. And so you inherit it. It's a contract that has been written before, and then you inherit it into your own contract. So we have different ways of inheriting a contract. We can have single and we have multiple inheritance. Single inheritance and multiple inheritance. So we're going to look at a code that tells us an example of using or inheriting a code, a contract. So this is an example of a code that inherits from another code. We can see here, there is a contract here called parents. It has a state variable and a function. And then you have another contract. Then you see what we mean here when we talk about inheritance. When we talk about inheritance, you use the keyword is. So when you say contract child is parent, it simply means that you are inheriting the code of the contract of the parent contract. You're inheriting the code of the parent contract. It's just like in our day-to-day activities and life. When a child inherits something from a parent, then that thing automatically belongs to the child. It's now for the child. So that's how this one is too. So when you say child is parent, it means that all the functions in this contract, parents, now belongs here in this child contract. So you now have a function here also. So it means it's just like you saying that these functions here are still here, and then you are adding a function. So like you can see, this function is returning sum, but you see that sum is not here in this contract, but then we can find it in the parent contract. So it's returning the sum because it has already inherited it. If not, then this will throw an error because there's nothing like sum in this contract. But because the sum exists in this parent contract and it has been inherited, then you can make use of it. You can then return this sum. And so it's okay. So this is when using inheritance in Solidity or smart contracts, you must use the keyword is to show that you have inherited a contract that is not, and then the functions of that contract can then be used in your own contract. So this is a kind of case that is similar to the one we used in library. It's not compulsory for you to have the contract that is being inherited in the same code. You can simply remove this contract, this parent contract, and then import it. It's saved somewhere else, and then you import it just as we imported the library. It's the same procedure. You can simply remove it and then save it somewhere else in another folder, and you import it. So we use the same method that we use to import the libraries. We use the same method that we use to import the libraries when importing contracts that are inherited in Solidity. So they are very similar, but then the difference here is you use the keyword is when you are inheriting a contract, showing that the contract that is inheriting, which is the derived contract, now has the codes of the parent contract, which is the base contract. You must use the keyword is when we talk about inheritance of a contract. So well, if we can look at it this way, that when we talk about in libraries, you import it to use in your contracts. But then when you talk about inheritance, contracts, you inherit them. You inherit them to use in your contract, and you can import them, or you can have them right there in your contract. But then you must use the keyword is to show that you inherited the contract, that the contract you are using is not, the functions are not inside your own contract, but they are from another contract, but you are inheriting those functions to use in your own contract. So that's the similarities and between when we talk about libraries and inheritance in smart contracts. So we'll go now to oracles. So what are oracles? When we talk about oracles, what do we mean? These are data feeds that connect Ethereum to off-chain. It means that, like, it's any device or entity that connects the blockchain with off-chain data. So they enter data on the blockchain through an external transaction. And so the blockchain has any information that it needs in order to verify itself. Instead of calling an API, we can use Oracle to get the reports, to report it on chain to the blockchain. So it's just like a bridge to bridge the blockchain to the real world, just like bridging the blockchain to the real world. And so we can refer to them as trusted source of truth, because the oracle can give us accurate information that can be used in the blockchain, in order for it to be able to verify itself. So what are the use cases of oracles? How can the blockchain use oracles? We can talk about them in these three ways: whether, price, or random number. For example, when we talk about price, when we talk about whether, we're talking about insurance contracts. If you have insurance contracts on the blockchain, and then the insurance contracts need to know for farm insurance contracts needs to know the current state of the weather at all times for it to be able to pay the insurance money to the parties involved. So at this point, we need an oracle, because an oracle is a smart contract. So it's a smart contract that is connected to off chain, in that it gets information. It's similar to the way the blockchain is designed, because it's connected to different networks, and so it's connected. This different network pass the information through the oracle smart contract to the blockchain, which is on chain to the blockchain. And so that information that is passed from those nodes, it's passed to the Oracle smart contract. So the information doesn't change. The information doesn't change because if you want to get the information about the weather at different times, it changes. But then when the nodes already confirm this information and then pass it to the Oracle contract, then the Oracle contract has that information. It doesn't change. It's now on the blockchain. And then the blockchain can refer to that information for it to verify a transaction at any given time. So that's for an application of it or a use case, weather. And then we also have the price. You can also use oracles for price of cryptocurrencies. So the price of Ethereum and other cryptocurrencies, you need it so that for it to be used or to be able to do anything in DeFi. Because if someone wants to transfer or exchange his token, you need the like present rates, the present rate of that is different tokens, so that you'll be able to accurately calculate the equivalent in the token that the person wants to swap it with. And so this Oracle smart contract has this information, gets this information from off-chain to on-chain, and then it's being used on the blockchain to verify transactions. So we can also apply this to random number, like in a game of guess and win. So if you have to, maybe you are interacting with a smart contract and then you give your own guess, like in a game of guess and win, you give your own guess, and then the smart contract gives you a guess, which is like you are to compare the guess that the smart contract gives you with your own to tell if it's the same. And then if it's the same, that means you have won. But if it's not the same, that means you have lost. So if you need the blockchain has to go and be fetching the guess at different times, it will change. But if it's done by a smart contract, that is the Oracle smart contract, then they can use that exact guess that the smart contract has provided to verify if your own guess, the transaction is correct or not. So these are the ways that Oracle smart contracts are used. So that's why we say it's also a case of code reuse. It's a smart contract that is on the blockchain that connects the blockchain to off-chain that can be used from time to time. So an example of this Oracle code will be an example of this Oracle code is Chainlink. Chainlink provides us with this decentralized oracles, decentralized oracle that solves the problems of having to call an API to give you information off-chain, to supply information off-chain to on-chain. So Chainlink is actually solves that problem of providing standards for decentralized oracles that we can use on the blockchain. So, and the code, the smart contract, the Oracle smart contract is something that I'm going to make that into a video for you guys to follow along, because it's going to take a lot of time. It's not something that we can just explain here together with these libraries and inheritance. So it's going to be made into a video so that you guys can follow it, like can watch it and then understand what these Oracle smart contracts really are. So, Oindamola, I don't know if we have questions now.
Yeah, thank you very much, Happiness. Can you hear me?
Yes, I can hear you.
Yes. So we have some questions here. The first question is that why why exactly does what exactly does safe math does? What does it do? Safe math. Do you want to answer that?
Okay. Safe math actually deals with the problem of overflow and underflow in smart contracts.
Contract. Yeah.
That is what safe math does.
Okay. Thank you very much for that. The next question. When and why do I need to use a safe math library?
Okay, that's actually connected to the first question. So it's the same answer to deal with or handle the problem of underflow and overflow in smart contracts. So that's what will make you to use a safe math
Safe
library.
math. Yeah. Thank you very much. I think that answers the question. So, the next question is okay, what are other use cases that will be required for me to use Open Zeppelin library?
Okay, so like I said, when you use a library, it simply means that there's a code that you need that has been written. You want to bring it into your smart contract. So there are various libraries in Open Zeppelin. There are various libraries code in Open Zeppelin. So it's just for you to read their documentation, for you to know what they offer, so that you can know which of the libraries that you would need in your own code if you are writing a code. So, like in Open Zeppelin, an example is that they have standard implementation of tokens like ERC 20 tokens, ERC 721, and other tokens. They have a standard implementation of these tokens that you can inherit. Okay, that's inheritance. But you also have other libraries that you would want to use, you want to use in your code. And so since they have it, there will be no need for you to start writing such codes again. Well, it's your choice. But if since it already exists somewhere, you can simply import it into your code and use it.
All right. I think that answers it. Additional to what Happiness just said, we have several libraries. We have um, access control libraries. We have um, ownable libraries. This is a library that allows you to use a modifier that allows only the owner of the contract to call a function. So we have several libraries. So, like Happiness said, you need to go through Oppositepolin's GitHub and their documentation to know which libraries would fit your project. So, thank you very much, Happiness. So, um, another question that we have here: does current Solidity compiler still pay attention to save math? I think I can take that. No, you don't need um current Solidity compiler version. I'm sure of 0.8.12 does not need save math, but 0.8 to I think 0.10, I'm not so sure. You can do your own research on that. Yes, you definitely need safe math for those versions. So another question: what is an external libraries and how can it be modified? So I think Happiness explained. Happiness, do you want to take this?
Yes, like you're about to say, I already explained what an external library is. It's simply
Yeah.
code that you are not the one who wrote it. It was written by someone else, or like an example, Open Zeppelin, and it's saved. So either by you or by them, but you want to use that code in your own contract. So that's an external. Okay, internal library is the one that you yourself wrote.
Mhm.
It's saved by
Yeah,
you.
important.
But an external library is an example of it is the Open Zeppelin. So you are not the one who wrote the code. So you want to use it, your own contract. So you can import it into, because it's not inheritance, it's a library. You can import it into your own contract. And then since you have the code, you can change it if you want. And so in that way, you are modifying it.
All right, thank you for that, Happiness. So another question we have here is how does interface work?
Okay, interface it's actually not an exact contract. It's just like how would I put it? Like a skeleton, a framework of a contract that you want to make use of in your own contract. So that's what an interface is. And when using an interface, you use the keyword interface because it's not a contract,
Okay.
but it's just a skeleton or a framework that of a contract that you want to
Mm.
make use of. So you can use interface to interact with a deployed contract by just providing the address of the deployed contract. So that's what you use interface. Since you want to interact with that contract, you can make use of the interface to interact with it by just providing the address of the deployed contract. So you don't need to write on the contract code. You don't need to write the contract code to interact with the contract. You just need that interface that's like a skeleton to interact with it. So that's how the interface works.
Okay, thank you for that, Happiness. So I think we have another question here. How can you inherit a contract from an imported library? Okay, I think I can take this. When you say libraries are different from contracts. So you don't call them contracts, but libraries, and you can only import them by using the keyword import, just as Happiness is showing it on our screen. That line for imports, then libraries, and the file's name. Yeah, so that is how you import a library, and you don't call them like a contract. So they are not contract, they are libraries. So libraries are different from contracts. Contracts are full-fledged, like, yeah, are standard contract, while libraries are just like a framework that you can use in your code. Okay, so another question that we have here: how does it get the accurate weather update? Does the node of the Oracle connect to an API? Happiness, would you like to take this?
Okay, so sort of. I'm going to do a video on how we can use Chainlink to accomplish this. But like I said earlier, the the Oracle, it's a kind of API. So you don't use the normal API that we know, but you use the Oracle. So it's a kind of API that connects, but it's just that it connects the off-chain to the blockchain, to on-chain. So the Oracle code or smart contract, it's on chain, but it connects off chain with its nodes that it uses to get information from off chain, that is the outside world, to the blockchain. So that's how it works. It's a kind of API on its own. A kind of API on its own, but it's called an oracle. It's called an oracle. So I'll do a video on how we can use Chainlink, which provides this standard for decentralized oracles to accomplish this.
All right, thank you so much, Happiness. So the last question we have here is how do I call function from the library? Happiness, do you get that?
Oh yes, sorry. I was already talking. I didn't know I was muted. So I have
Okay.
to share my screen to. Sorry about that. So you can see this contract here. We're making use of libraries, the Safe Maths library and the Maths library. So what was the question again, please? Can you repeat the question?
Okay, let me do that. So how do I call functions from the library?
Okay, thank you. So you can see there are basically two ways that we can do that. If you look at this first function here, that is called test add. Then we can see this one here, function that is test square root. So if you look at this math is a library here. Here. And then this square root is a function here, square root. So you are calling this function of this library in your contract here by saying math dot square root and then putting the variable. It's a uint variable here, and then you are passing the variable here, the uint. So in this way, you are calling that function square root of the library math in this your contract here, in this function test square root. So I'm sure that answers the question. Okay, I mentioned that there are two ways. And so this is another way. In this function test add, you can see that you are also calling a function from this safe maths library. This safe maths library has a function named add, and then that receives two variables, uint, a uint and another uint. So right here, we are going to be calling it by using, you see, this in this way, we use the function name here. But since we already, the library name, I mean to say, dot the function name. But since we already specified here using safe math for uint, we can simply use the variable, one of the variables, dot the variable name x dot the function function name. Yes, that's the add function of the library. Look at it here. this library has a function add. We can simply use the variable name x dot the add function of the library and then pass the second variable, the second uint variable, into it. So those are the two ways that we can actually call a function, a library function in our own contract. Hello, did you get me?
Yes. I think that answers the question. Thank you very much. So I think that is all we have on the live chat. So is there anything from Chikere? Do we have anything else to discuss?
No, we don't have anything else to discuss.
All right. So I guess this is the end of our live session for today. And if there are further questions, you can drop them on the Discord channel and tag Happiness for more explanation and to answer your questions. So thank you for coming, everyone. Thank you so much.
Okay,
Happiness, thank you
so much.
for the presentation.
Thank you, Ndamola.
Yes, you're welcome.
Thank you. Good night.
Good night, all.
All right, goodbye. Have a nice night.